Welcome to this session on class relationship in Java. This is Namada Krishna P. Suresh, and today we will explore how classes interact with each other in object oriented programming and why understanding this relationship is essential for building strong and scalable software. Here, what we will cover today, we will start with an introduction to class relationship followed by inheritance, the easy relationship. Next, we will dive into composition, the has a relationship, and then we will discuss association and aggregation to understand border connections. After that, we will look at polymorphism in action. We will also explore a live demonstration using IntelliJ IDEA. Finally, we will wrap up with key takeaways to reinforce what we have learned. In Java, class relationship define how different classes interact and work together. Think of each class as a Lego block. By connecting these blocks in different ways, we can build complex structures like applications. These relationships make our code modular, reusable, and easy to maintain. Inheritance is one of the core concepts of OOPS. It allows a new class called a child or subclass to inherit methods and fields from an existing class known as a parent or superclass. This forms an is a relationship. For example, a car is a vehicle. The key benefits include code reuse, easier maintenance, and polymorphism, which let us treat different subclasses as one common type. Composition that has a relationship. Composition works differently. Instead of inheriting features, a class contains object of other classes. This is called a has a relationship. For example, a car has an engine. Composition provides flexibility because parts can be swapped or changed without affecting the entire system. It also promotes high cohesion and low coupling, which makes our software more organized and easier to maintain. Association and aggregation. Association is a basic connection between two classes, whether either wants the other. For example, a student can be associated with a course. Aggregation is a special type of association that represents a whole part relationship, but where the parts can exist independently. For instance, a department can aggregate professors. Even if the department closes, the professors can still exist on their own. Polymorphism in action. Polymorphism means many forms and it allows us to treat different objects as if they were the same type. This makes our code more flexible and adaptable. In Java, polymorphism happens in three ways. First, method overriding, where a subclass changes the behavior of a method defined in its parent class. Second, inference implementation, where classes promise to follow a specific structure allowing interchangeable objects. And the third, dynamic method dispatch, where Java decides at runtime which method to execute based on the actual object type. Demonstration with IntelliJ IDEA. Now, let's bring all these concepts together with a practical demonstration using IntelliJ IDEA. We will bring a simple university management system to show inheritance, composition, and polymorphism in action. Along the way, we will use IntelliJ's powerful tools like code completion, syntax highlighting, refactoring, and debugging to improve productivity and code quality. In this slide, we showcase our live coding session where we built a university system from scratch using IntelliJ IDEA. We created classes for students, courses, and department, connecting them using inheritance, composition, and association. This practical demo brought out our theological concept to life and showed how easily these relationships can be implemented. The flow of execution is creating an object, a new department is created, the professor and the student object are added to it, the course object are created and linked to students and professor using inheritance. When you create display details on a student or professor, they inherit the method from person. This avoid code duplication using polymorphism. Suppose you have a list of person object that include both student and professors. When you iterate through the list and call a method like show role, the correct version of each object type runs dynamically at runtime. This slide shows the result of the program that built during the IntelliJ IDEA demo, especially the university management system. The goal here is to connect theory with practice and show how the concepts of inheritance, composition, association, and polymorphism actually work together. The key points to conclude, here are the final key points to remember. Relationships between classes are crucial for designing organized and scalable Java programs. Use inheritance for shared behavior, composition for flexibility, and association or aggregation to model real world connection. Polymorphism brings flexibility by allowing different objects to be treated in a uniform way. And lastly, always leverage tools like IntelliJ IDEA to code more efficiently and debug effectively. With these skills, we are ready to design better, more maintainable Java applications. By this, let me conclude. Thank you.